In this session, we will see how to reduce a given logic expression or equation using Quine McCluskey method. This Quine McCluskey method is also known as tabular method. We will start the procedure. First, we have to represent each of these min terms in binary form. Here the maximum number is 15 and it requires 4 bit in binary. So we are going to represent each min terms in 4 bit. So the first min term as given in the question is 0, second one is 1, then 2, 3, 6, 7, 8, 9, 14 and 50. So these are the min terms given in the question. Now we are going to write the corresponding min terms in 4 bit binary. So for 0 it is 0, 0, 0, 0, then 0, 0, 0, 1, and for 2 0, 0, 1, 0, 3 is 0, 0, 1, 1, 6, 0, 1, 1, 0, 7, 0, 1, 1, 1, 8, 1, 0, 0, 0, 9 is 1, 0, 0, 1, 14 is 1, 1, 1, 0, and 15 is 1, 1, 1. So these are the 4 bit binary representation of the given min terms. As a first step, we will create a table and we will name it as table 1. In this table, we have a column known as group, then min term, and the variables. The variables, since here we have 4 bit, so I am taking 4 variables A, B, C, and D. So these are the columns. First we will write group 0. That means the min terms having no ones in it. The min terms having no ones in it means we have only the min term 0 present in that. In 0, when we write it in binary, we can see there is no 1 in it. All we have is 4 zeros. So group 0 means there is no 1 present in the binary representation. So the min terms with group 0 is only one min term, that is 0. And in the binary representation, we can write it as 0, 0, 0, 0. Next, we will see group 1. Group 1 means min terms having only one ones. So we will see this. We have 1, it contains only one 1. 2, it contains only one 1. Then 8, it contains only one 1. There are 3 min terms in group 1. So they are min terms 1, 2, and 8. In the binary form, we will write it as 0, 0, 0, 1, 0, 0, 1, 0, and 1, 0, 0, 0. So these are the 3 min terms under group 1. Next, we will see the min terms under group 2. That means min terms having 2 ones. So there it is. 3 is there, 6 is there, and 9 is there. Only 3 mintimes. So we will see that. So we will write those mintimes under group 2. That is 3, 6 and 9. When we write it in binary, it is 0, 0, 1, 1 and 6 is 0, 1, 1, 0 and 9 is 1, 0, 0, 1. And next is group 3. Group 3 means mintimes having 3 ones in it. You can clearly see 7 is there and 14 is there. So mintime 7 and 14. For 7 it is 0, 1, 1, 1 and 14 is 1, 1, 1, 0. And next is group 4. That means having 4 ones. We have only one group, that is mintime 15. We can write it as 1, 1, 1, 1. And this is table 1. So this is how we group the given set of mintimes into table 1. Now we are going to create the next table, table 2, using same headings. So we will create the next table. It contains the same headings, that is group, mintimes and variables. So what we are going to do here is we are going to compare the adjacent groups. That means we are going to compare group 0 and group 1. That means we are going to compare each mintime of group 0 with each mintime of group 1. And similarly, we are going to compare group 1 with group 2. That means each mintime of group 1 will be compared with each mintime of group 2 as shown in the figure. That means group 1 contains mintime 1, 2 and 8 and 1 is compared with 3, 6 and 9. Similarly 2 is compared with 3, 6 and 9 and similarly 8 is compared with 3, 6 and 9. And similarly group 2 is compared with group 3 and group 3 is compared with group 4. So we will see this in detail, how we are going to compare it. We will see. First, we are going to compare group 0 and group 1. First, we will see 0 with 1. We are going to compare 0 with 1. If there is only one bit change in 0 and 1, then we will write it here. First, we are going to compare group 0 and 1. So we will write group 0 here. That means we are going to compare group 0 with 1. So we will check 0 and 1. We can see A is same for both 0 and 1. B is same for both 0 and 1. C is same for both 0 and 1. But D is different. Here it is 0, here it is 1. But no problem. There is only one bit change. So we will consider only if there is one bit change. If there are changes in more than one bit, then we will not consider that mintimes. Here we can consider because only D is changing. All other variables A, B and C remain same for 0 and 1. So I will write here it as 0, 1 because we are considering mintimes 0 and 1. So I will write it once again. Since we are considering group 0, or we are going to compare group 0 with group 1, so we are going to write here it as group 0, because we are going to compare group 0 elements with each elements of group 1. First we have compared 0 and 1. Meantime 0 and 1. 0 is group 0 and 1 is group 1. Only one bit change is there, only D is changing. So we can write it as 0, 1. And here A is 0 for both 0 and 1. B is 0 for both 0 and 1. You can check. And C is 0 for both 0 and 1. But D is different. So we will put a dash there. And now we will compare the next one, 0 with 2. If we compare 0 with 2, what will happen? Can we do that? A is same for 0 and 2. B is same. C is different. And D is same. Only C is changing. All other three bits are same. So we can write that also. So next group 0 is maintains 0 and 2. They will have 0, 0. C is changing. So put a dash there. And D is 0 in both the cases. Now next comparison is maintain 0 and 8. A is different for 0 and 8. A is 0 for 0 and A is 1 for 8. And the remaining BCD are same. All are zeros. So we can take the next element, that is 0 and 8. We will have dash 0, 0, 0. And this is comparison of group 0. All the elements of group 0 is compared with all the elements of group 1. And now we will see about group 1. That means group 1 should be compared with each elements of group 2. So first we will compare minterm 1, that is group 1's first minterm. Minterm 1 with group 2's first minterm, that is 3. So if we consider 1 and 3, we can see this is 0 and this is 0. For A, both 1 and 3 is 0. For B also 0. For C, it is different. For C, here it is 0, here it is 1. And for D, again same, both are same, it is 1, 1. So this we can take. We can take 1, 3 because only C is different. All other variables are same. Okay, so for this we can write it as 1, 3 and A is 0, B is 0, C is different. You can see here, C is different. All other variables are same for both 1 and 3. So for C, we will write it as dash. And for next one, it is 1. Now we will consider the next comparison, that is 1 with 6. You can see here, 2 bits are changing. Variable B and C are changing. So we cannot take 1, 6. We can take only the pair if only single variable is changing. Here two variables B and C are changing. So we cannot consider this. We are going to take the next comparison, 1 with 9. We can easily take that because only the first bit is changing. Therefore, we can write it as 1, 9. That is dash B is 0, C is 0, and D is 1. We have compared 1 with all the min terms of group 2. Now we will compare 2 with each element of group 2. First, consider 2 with 3. We can see only D is changing. All other bits remains same. All other bits remain same. This is A is 0 for both the cases, B is 0 for both the cases, and C is 1 for both the cases. So we can take the pair 2, 3. We will write it as 2, 3. That is 0, 0, 1, dash. Now we will compare 2 with 6. We'll compare 2 with 6. If we compare 2 with 6, whether it is possible, can we take the pair? If we closely look, A is same, B is different, C is same, and D is same. So 2, 6 is okay with A 0, B is different, so put a dash, C is 1 for both, and D is 0 for both 2 and 6. Now consider 2 with 9. If we consider 2 with 9, we can see the first bit is changing, second bit is same, third bit is changing, and last bit is changing. So we cannot take 2 and 9. We can consider only if there is a single bit change. Now we will move to the next min term of group 1, that is 8. We will first consider or compare 8 with 3. If we compare 8 with 3, we cannot take it because A is different, C is different, and D is different. So next we will compare 8 with 6. If we compare 8 with 6, again we cannot take because more than one bit is different. Now we will consider 8 with 9. This is okay because only D is changing. So we can write it as 8, 9. A is 1, B is 0, C is 0, and D is dash. And therefore, we have completed all the comparison of group 1 with 2. So we will close this group. Now we will go to group 2. That means comparison of group 2 with group 3. First, 3 with 7. 3 with 7 means first A is okay, B is different, C is okay, and D is okay. Only B is different. So we can consider the group 3 and 7. 3, 7. That is 0, dash, 1, 1. Now we will consider 3 with 14. No, we cannot take it because A and B are different. And now the next number, that is 6 with 7. Yes, we can consider 6 and 7. 6, 7. Only the last bit is different. So 0, 1, 1, dash. Next, 6 with 14. When we compare 6 with 14, first is okay, B is okay, C is okay, but D is different. If we consider 6 and 14, the first bit is different. Here it is 0, that is A is 0, and here it is 1. All the remaining are same. we can write the pair 6, 14, that is dash 1, 1, 0. Now we will compare 9 with 7 and 14. First, 9 with 7 you cannot consider because more than one bit is changing. Now 9 with 14, again that also we cannot consider because more than one bit is changing. When 9 and 14 are compared, B is changing, C is changing, and D is changing. So we cannot take. So this is all about group 2 comparison. So we will close group 2 comparison. Now we will move to group 3. We are going to compare group 3 with group 4. First we will see comparing 7 and 15. Only first bit is changing. So we can write it as 7, 15, that is dash 1, 1, 1. Now we will compare 14 and 15. We compare 14 and 15, only last bit is changing. So we can write it as 14, 15. It is 1, 1, 1 dash. So we have compared all the minterms with all the minterms of other groups. Now the next table, that is table 3. Again, we are going to do the same procedure as we have done in table 2. We are going to compare each minterm of group 0 with each minterm of group 1. Similarly, each minterm of group 1 with each minterms of group 2 and each minterms of group 2 with group 3. So first we will see group 0. That means we want to compare 0, 1 with each elements of group 1, 0, 2 with each elements of group 1, and 0, 8 with each elements of group 1. So there is a shortcut to do the same. First we will compare 0, 1 with each elements of group 1. To do the same, first we have to see where is the dash coming for the pair 0, 1. It comes under the variable D. So in group 1, just look at the variable D, whether there is any dash. So we have 2 dash there. So if there is no dash in the particular column where 0, 1 have dash, in group 1, if you don't have these 2 dash, if there is no dash in these 2 row, these 2 places, then there is no group with 0, 1 and any of these minterms in group 1. So since we have dashes on the same place where 0, 1 have in group 0, we have some chances of grouping. We will check it. So we need to consider only this 2, 3 and minterms 8, 9 because only dashes are present in the same place for these 2 minterms. So other minterms we don't need to consider. So in this case, check for 1 bit change. So first compare 0, 1 with 2, 3. Compare 0, 1 with 2, 3. 0, 1, 2, 3. When we compare, already D have dash, then C is different. C is different, but A and B, they are same. So only 1 bit is changing, that is C, and A and B remains at 0, D remains at dash. So we can consider the pair 0, 1, 2, 3. So I'm writing the pair 0, 1, 2, 3. The variables A is 0, B is 0, C is dash because they are changing, and D is already dash. Now the next one. So we have checked with 2, 3. Now the next one is 8, 9. It contains the dash in the same place as of 0, 1. So when we consider 8, 9, again only A is changing. You can see only A is changing. B is same, C is same, and D is dash. So we can take 0, 1, 8, 9 also. So 0, 1, 8, 9. A is changing. So dash, B and C are 0, and D is already dash. So we have completed comparing the consecutive groups, all the min times in a consecutive groups. And this is table 2. Now we are going to create table 3. So we will draw the table 3. I am writing the pair 0, 1, 2, 3. The variables A is 0, B is 0, C is dash because they are changing, and D is already dash. Now the next one. So we have checked with 2, 3. Now the next one is 8, 9. It contains the dash in the same place as of 0, 1. So when we consider 8, 9, again only A is changing. You can see only A is changing. B is same, C is same, and D is dash. So we can take 0, 1, 8, 9 also. So 0, 1, 8, 9. A is changing. So dash, B and C are 0, and D is already dash. So this ends group 0. Now we will see group 1. Sorry. Before that, we have to consider the next min term. We have to compare 0, 2 with all the min terms in group 1. So first, we have to consider 0, 2. So now we have to consider the second min term, that is 0, 2. We have to compare 0, 2 with all the min terms of group 1. So for 0, 2, the dash is coming in the variable C. We have to look at group 1 where this dash is coming. So here the dash is coming. So we have to compare only this 0, 2 with 1, 3. But 0 to 1, 3 is already available. You can see here. 0 to 1, 3 is available here. Just the order of min terms is different. 0 to 1, 3 is available here. So it is already in grouped state. So we don't want to write it once again because that is already grouped. So there is nothing else to compare for 0, 2. Now next is we have to consider 0, 8. For 0, 8, the dash is in the variable A. So here also there is a dash. So we have to compare 0, 8 and 1, 9. But it is already available here, 0, 8 and 1, 9. 0, 8, 1, 9 is available here. So it's already grouped. So no other min terms have dash in the first variable A. So we have compared all the min terms of group 0 with all the min terms of group 1. Now we will go to group 1. In group 1, we have to compare each min terms of group 1 with each min terms of group 2 as per the same procedure we have done for group 0 comparison. So first we will check min term 1, 3. For min term 1, 3, we have the dash in column C, but there is no dash for group 2 in column C. So there is no group starting with 1, 3. So we will move to the next group, min term group, that is 1, 9. So for 1, 9, the variable A has a dash. So in group 2, we have a dash here, the same place. We will compare 1, 9 with 640. So first A has common place, dash in the common place. And if we consider B, it is changing. If we consider C, it is also changing. If we consider D also, it is changing. So it is not possible to take that group because we need only one bit change. Here 3 bits are changing. So that comparison is over. Now we will see the next min term, that is 2, 3. We will compare 2, 3 with group 2 members. So if we consider 2, 3, the dash is in variable D, and in group 2 also we have a dash. If we compare, C is same, D is different, the B is different, and A is same. So we can take this because A, C and D is same, only B is different. So we can take the pair 2, 3, 6, 7. We can take the pair 2, 3, 6, 7. 2, 3, 6, 7. And we have 0. B is different. C is 1. And D is dash. Next, we will compare with 2, 6 and the min terms of group 2. For the min term 2, 6, we have dash in variable B. Here in group 2, we have only one dash, that is in 3, 7. So if we see 2, 6, 3, 7 is already available. 2, 3, 6, 7. The numbers are interchanged, but 2, 6, 3, 7, the group is already available. So we there is no need to check again. Now we will go to the next term, 8, 9. For 8, 9, we have dash in D. So if we check the group 2, we have one dash, and it is 6, 7. So if we check the variable C, we have 0 here. Here there is one bit change already, okay. And for variable B, here it is 0, here it is 1. So 2 bits change, okay. So we cannot take it. If the change is more than 1 bit, we cannot take it. So 8, 9, 6, 7 is not possible. Now we will check 8, 9, 6. Only one case is available because dash is available for only one case in group 2. So all the in terms of group 1 is compared with group 2. Now we will check the group 2. So in group 2, we have to compare each elements of group 2 with group 3. First we will see 3, 7. For 3, 7, the dash is at the variable B. If we go down, there is no dash in group 3, the same column. So we cannot group 3, 7 with any other min terms of group 3. So next one is 6, 7. If we take 6, 7, there is a dash in group in variable D. So here also there is a dash. If we see C, variable C, it is same. Variable B, it is same. And variable A, it is different. So only one bit change. All the remaining are same. We can take the group 6, 7 and 14, 15. 6, 7, 14, 15. So I'm going to write that pair here, that is 6, 7, 14, 15. Only the first bit is different, all other are same. Now the next one, that is 6, 14, we have dash in the first variable A. In the third group also we have dash. So if we check the remaining variables, B and C are same, C and D are same, so C and C are same, and for D also in both group it is different. C in D it is different. The first three variables are same, only the last variable is different. So we can take that group also. We can take that group also. But next we will consider the group 6, 14, then 14, 15. Actually, it is not possible because here there is dash, but 614 with 715 is possible because dash is in the same place. But already this 614, 715 we have already taken. So there is no need of another group. So we have completed all groupings from table 2. Now we have to consider the next table. If it is possible, if grouping is possible, we will check. First, we have to check group 0 with group 3. We will check group 0 with, group 1. Group 0 with group 1. So first group 0, 1, 2, 3. First group, we have 2 dashes. So we can group only if 2 dashes are in the same place in group 1, but it is not. They are in different places. And therefore, we cannot group 0, 1, 2, 3 with 2, 3, 6, 7. And now we will check the next min time 0, 1, 8, 9 with 2, 3, 6, 7. So we have 2 dashes here, and for 2, 3, 6, 7, the group 1, the 2 dashes are in different place. So again, it is not possible. Now we will check group 1 and group 2. Only 2 min time groups. For group 1, we have dashes in B and D, and for group 2, we have dashes in different place. So it is not possible. So we cannot group further. So this is the final table. So in order to find the simplified expression, we need another final table, that is table 4. We will see that. We have the final table, and this is table 4. In table 4, we have the PI terms. PI terms means the prime implicant terms. I will explain it soon. The next one is we have the decimal numbers. And next we have the min terms. Min terms is what which is available in the question. That is, you can see here, the question, the min terms are available 0, 1, 2, 3, 6, 7, 8, 9. These are the min terms. So this we have to write it there. If you write these min terms, this is 0, which is given in the question, 1, 2, 3, 6, 7, 8, 9, 14, and 50. We'll separate it with columns for better understanding. Here is the table. We will see what is this prime implicant terms. PI is prime implicant. Prime implicant means the variables which obtained in the last table in each group. So here the first prime implicant for these min time 0, 1, 2, 3 is, we will see, first prime implicant for this row or for the min time 0, 1, 2, 3. We will write the decimal number as the corresponding min times 0, 1, 2, 3. The prime implicant is we don't want to care C and D. This is dash. That means like don't care. We have only A and B and their value is 0. So we should write A bar, B bar. So this is the first prime implicant. And we have to write it as A bar, B bar. Now we will see the second prime implicant for the mintype 0189. So 0189. So for that the prime implicant is it is B bar and C bar. A and D are don't care. So it is B bar, C bar because B and C are 0. Now for the third group of mintypes, that is 2, 3, 6, 7. The prime implicant is A bar, C is 1. So C, A bar C, A bar C. And now for the last group, that is 6, 7, 6, 7, 14, 15. We have BC. So these are the prime implicants: A bar, B bar, B bar, C bar, A bar, C, and BC. Now we have to see where and all these minterms are present. So here 0 is present. Put across. 1 is present for this decimal number or this minterm. 2 is there, 3 is there. And here 0 is there, 1 is there. There's a comma. Then 8 and 9. 8 is there, 9 is there. For this 2, 3, 6, 7. And for the last one 6, 7, 14, 15. So this is the final table. And it is also known as prime implication table. Here what we need to consider is we want to check in our final answer. Actually these prime implicants, all these terms are available in our final answer, that is A bar, B bar. Our final answer will be like this: A bar, B bar plus B bar, C bar plus A bar, C plus BC. But it may not be the simplest expression. Sometimes we can avoid some of this prime implicant. There are 4 terms. Sometimes we can avoid 1 or 2 terms. So for finding that, we are drawing the last table, table 4. So how to find that? We will check. So here we want to check for any minterms. If for any minterms there are several minterms 0, 1, 2, 3, 6, 7, 8, 9, 14, 15. If for any minterms it is crossed in only one row. For example, here 0 is crossed in 2 rows. 1 is crossed in 2 rows. 2 is crossed in 2 rows. If you go on checking, we can see 8 is crossed only in 1 row. So you just encircle it. 9 is only available in 1 row. Therefore, you can clearly see 8 and 9 are available only with the prime implicant B bar, C bar. Therefore, the prime implicant B bar, C bar is essential. It is known as ESI, essential prime implicant. It is known as essential prime implicant. That means it is essential in the answer. We cannot avoid B bar, C bar. So I made a mistake here. It is not in BC. It is B bar, C bar. 8 and 9 are available in the prime implicant B bar, C bar only. So this B bar, C bar is not avoided, or it cannot be eliminated from the answer. It should be available in the answer. And similarly, you check next one, 14 and 15. 14 is available only in one prime implicant, and 15 is also only available in one prime implicant, that is in BC. So this BC is also not avoidable. So in our final answer, we need both B bar, C bar and BC. So what about this A bar, B bar? or AC. That means this A bar, B bar or AC. If we check 0, it is available with A bar, B bar and B bar, C bar. So since it is available in B bar, C bar and we have already taken it in the answer, we can eliminate this. We don't need this because we don't need duplication. 0 is available with B bar, C bar. So A bar, B bar is not required. And 1 is also available with B bar, C bar. So A bar, B bar not required. And now check 2. 2 is available with A bar, B bar and A bar, C. It is not in the answer. It is not in the answer. So we should take either A bar, B bar or A bar, C. So our answer should contain either A bar, B bar because it is available in both. We don't need to take both. So our answer should contain either A bar B. Sorry, our answer should contain either A bar, B bar or A bar, C. Because 2 is available in A bar, B bar and A bar, C. I have written A bar, B bar, or our answer should be like this. B bar, C bar plus BC plus A bar, C. So this is alternate answer. So 2 can be available in either A bar, B bar or A bar, C. We don't want to write both. Similarly, 3. It should be either available in A bar, B bar or A bar, C. And about 6 and 7, both are available in BC. It is already mentioned. It is already an essential prime implicant. So it is already there. So only the case of 2 and 3, only the cases of this 2 and 3, it is available in both A bar, B bar and A bar, C. So we need either A bar, B bar or A bar, C. We don't need both. So we have two answers, B bar, C bar plus BC. It is essential in all the answers, plus A bar, B bar or plus A bar, C. So in the next class, we will see another example. So it will be clear.